Mounting outlets on round steel supporting columns using cast FS boxes and electrical metallic tubing or INT violates NEC 406.10. B2 because the boxes are not securely fastened in place and are subject to physical damage. Junction boxes are also not permitted to be used as outlet boxes as per NEC 404.9. Additionally, floor receptacles should be used instead of outlets mounted on the floor, according to NEC 370.17. Running the grounding electrode conductor, or GEC, for the 480/208 volts transformers in EMT without bonding the EMT on the end where it connects to the building steel violates NEC 250.24. C1 because the GC is not properly connected to the grounding electrode system. Mounting the disconnects for the transformers and the transformers themselves, way above 6 feet 7 inches, violates NEC 404.8. A2 unless an exception applies. However, it may be argued that exception number 2 applies since the disconnects are located above finished floor level. Additionally, the concern about someone shutting down the store power by throwing a disconnect could justify mounting the disconnects at a higher elevation. NEC 406.10. B2 states that boxes mounted in walls or ceilings and containing devices or outlets shall be securely fastened in place before devices or outlets are installed. NEC 404.9 specifies that junction boxes shall not be used as outlet boxes except as required or permitted by this code. NEC 370.17 requires that receptacles installed on the floor shall be contained in floor boxes or floor receptacles and shall not have exposed energized parts. NEC 250.24. C1 states that the grounding electrode conductor shall be connected to the grounding electrode system in accordance with 250.50 and 250.52. NEC 250.50 provides that the connection of the grounding electrode conductor to the grounding electrode shall be made in a manner that will ensure a permanent and effective ground. NEC 404.8. A2 specifies that where accessible, the operating lever of disconnect switches, circuit breakers, and general use switches shall be located within the height limitation of 6 feet to 7 feet 6 inches above the finished floor or working platform. Exception number 2 allows that where the location is above finished floor level, the operating lever may be located at a height greater than 7 feet 6 inches above the finished floor level. The NEC provides specific guidelines for electrical installations to ensure safety and proper functionality. Let's delve into the details of each violation and the corresponding code requirements. Firstly, consider the outlet mounting on columns. NEC 406.10. B2 is very clear that outlet boxes must be securely fastened. The intent here is to prevent the box from becoming loose, which can lead to strain on the wiring connections and potential hazards such as exposed wires or even electrical shock. In the scenario described, the outlets are mounted on round steel supporting columns using cast FS boxes and EMT. The problem arises when these boxes are not securely fastened, and external forces, such as forklifts, can easily dislodge them. When a box is knocked off a column, the EMT conduit can separate at the coupling, leaving the box hanging by the wires. This is a direct violation of 406.10. B2, as the box is no longer securely fastened. Furthermore, this situation creates a significant safety hazard. The hanging wires could be damaged, leading to short circuits or exposing live conductors. The exposed metal parts of the box and conduit could also become energized, posing a shock risk to anyone who comes into contact with them. In addition to the violation of 406.10, B2, the use of junction boxes as outlet boxes also violates NEC 404.9. Junction boxes are designed to provide a protected enclosure for wire splices and connections, not to serve as a mounting point for receptacles. While there are exceptions to this rule, such as when the junction box is specifically listed for use as an outlet box, it's generally not permitted. In the described scenario, the cast FS boxes being used are likely intended as junction boxes, not outlet boxes. Therefore, their use as outlet boxes is a violation of 404.9. Finally, NEC 370.17 addresses the installation of receptacles on the floor. This section requires that receptacles installed on the floor be contained in floor boxes or floor receptacles. The purpose of this requirement is to protect the receptacle from physical damage and to prevent water or other liquids from entering the electrical system. Mounting outlets directly on the floor without the use of a floor box or floor receptacle leaves the receptacle exposed to damage from foot traffic, equipment, and spills. This is a violation of 370.17. To correct these violations, several steps can be taken. Firstly, the outlet boxes must be securely fastened to the columns. This can be achieved by using appropriate mounting hardware, such as clamps or brackets, that are specifically designed for attaching to steel columns. The mounting hardware should be strong enough to withstand the expected forces and vibrations without loosening. Secondly, if junction boxes are being used as outlet boxes, they must be replaced with boxes that are specifically listed for use as outlet boxes. Alternatively, the receptacles can be relocated to a different location where they can be mounted in accordance with the code. Thirdly, if receptacles are being installed on the floor, they must be contained in floor boxes or floor receptacles. These devices provide a protective enclosure for the receptacle and prevent it from being damaged. Now, let's examine the grounding electrode conductor or GEC bonding. NEC 250.24 C1 requires that the GEC be connected to the grounding electrode system in accordance with 250.50 and 250.52. This means that the GEC must be connected to a grounding electrode, such as a ground rod, a metal water pipe, or the building steel, in a manner that ensures a permanent and effective ground. The purpose of this requirement is to provide a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent protective device and clear the fault. In the scenario described, the GEC for the 480/208 volt transformers is run in EMT up to the building steel. However, the EMT is not bonded in the end where it connects to the building steel. This means that there is no electrical connection between the EMT and the building steel. As a result, the EMT cannot serve as an effective grounding path for fault current. This is a violation of 250.24. Seat 1. To correct this violation, the EMT must be bonded to the building steel. This can be achieved by using a bonding bushing or a bonding lock nut to connect the EMT to the steel. The bonding bushing or lock nut must be properly tightened to ensure a good electrical connection. It's also important to ensure that the building steel itself is properly grounded. This can be achieved by connecting the building steel to a grounding electrode, such as a ground rod or a metal water pipe. Finally, let's analyze the disconnect location. NEC 404.8 A2 specifies that the operating lever of disconnect switches, circuit breakers, and general use switches must be located within the height limitation of 6 feet to 7 feet 6 inches above the finished floor or working platform. The purpose of this requirement is to ensure that the disconnect switch is readily accessible to authorized personnel in case of an emergency. However, there are exceptions to this rule. Exception number 2 allows that where the location is above finished floor level, the operating lever may be located at a height greater than 7 feet 6 inches above the finished floor level. In the scenario described, the disconnects for the transformers are mounted on the transformers themselves, way above 6 feet 7 inches. This is a violation of 404.8 A2 unless an exception applies. It could be argued that exception number 2 applies since the disconnects are located above finished floor level. However, it's important to consider the intent of the code. The code is intended to ensure that disconnect switches are readily accessible in case of an emergency. If the disconnect switches are mounted too high, they may not be easily accessible to authorized personnel. In this case, the concern about someone shutting down the store power by throwing the disconnect could justify mounting the disconnects at a higher elevation. However, it's important to balance this concern with the need for accessibility in case of an emergency. To correct this violation, the disconnect switches should be relocated to a location where they are readily accessible and within the height limitation of 6 feet to 7 feet 6 inches above the finished floor or working platform, unless an exception applies. In summary, The electrical code violations observed at the retail store include outlet mounting on columns, GC bonding, and disconnect location. These violations can be corrected by following the guidelines and requirements of the NEC. It's important to ensure that all electrical installations are code compliant to ensure safety and proper functionality. The NEC is a comprehensive set of standards that provides detailed requirements for electrical installations. Compliance with the NEC is essential to ensure the safety of people and property. When performing electrical work, it's important to consult the NEC and to follow all applicable codes and standards. If you're not qualified to perform electrical work, it's best to hire a licensed electrician. Licensed electricians have the knowledge and experience to perform electrical work safely and in accordance with the code. In the case of the outlets mounted on the columns, the repeated damage from forklifts indicates a design flaw or a need for better protection. Perhaps bollards or other physical barriers could be installed to prevent forklifts from striking the columns and damaging the electrical boxes. Additionally, using more robust boxes and conduit, such as rigid metal conduit instead of EMT, could help to withstand the impact. Regarding the grounding electrode conductor, proper bonding is crucial for safety. Without a proper bond between the EMT and the building steel, the EMT itself could become energized during a fault, posing a shock hazard. The bonding connection must be secure and corrosion resistant to ensure a reliable grounding path. The disconnect location is a more nuanced issue. While the NEC generally requires disconnects to be readily accessible, there are situations where it may be necessary to locate them in less accessible locations for security reasons. However, even in these cases, it's important to consider the potential impact on safety. If the disconnects are located in a difficult-to-reach location, it could delay the response to an electrical emergency. In such cases, it may be necessary to provide additional safety measures such as remote shut-off switches or clear signage indicating the location of the disconnects. It's also important to regularly inspect electrical installations to identify and correct any code violations. Regular inspections can help to prevent electrical hazards and ensure that the electrical system is operating safely and efficiently. Electrical systems are complex and potentially dangerous. It's important to take all necessary precautions to ensure safety. This includes following the NEC, using qualified personnel, and regularly inspecting electrical installations. By following these guidelines, it's possible to minimize the risk of electrical hazards and ensure a safe and reliable electrical system. The specific NEC requirements mentioned, such as 406.10, B2, 404.9, 370.17 and 250.24, C1, 250.50 and 404.8, A2, are just a small sample of the many codes and standards that govern electrical installations. The NEC is a constantly evolving document that is updated every 3 years to reflect changes in technology and best practices. It's important to stay up to date on the latest NEC requirements to ensure that electrical installations are safe and code compliant. In addition to the NEC, there may be other applicable codes and standards, such as local building codes and industry-specific standards. It's important to be aware of all applicable codes and standards when performing electrical work. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. If you have any questions about electrical safety or code compliance, consult with a licensed electrician or a qualified electrical inspector. The observations made at the retail store highlight the importance of proper electrical design, installation, and maintenance. Neglecting these aspects can lead to code violations, safety hazards, and potential damage to property. It's crucial for businesses and homeowners alike to prioritize electrical safety and to ensure that all electrical work is performed by qualified professionals. Regular maintenance, including inspections and testing, can help to identify and correct potential problems before they become serious hazards. For example, thermal imaging can be used to detect hot spots in electrical panels and wiring, which can indicate loose connections or overloaded circuits. Ground fault circuit interrupters, or GFCIs, should be tested regularly to ensure that they are functioning properly. Surge protectors can help to protect sensitive electronic equipment from voltage spikes. By taking these proactive measures, it's possible to significantly reduce the risk of electrical hazards and ensure a safe and reliable electrical system. Furthermore, consider the importance of proper training for employees who work around electrical equipment. Employees should be trained to recognize potential electrical hazards and to take appropriate precautions. They should also be trained on how to respond to electrical emergencies, such as power outages or electrical fires. A well-trained workforce is essential for maintaining a safe electrical environment. In addition to training, it's important to provide employees with the proper personal protective equipment, or PPE, when working around electrical equipment. This may include items such as rubber gloves, insulated tools, and arc-rated clothing. PPE can help to protect employees from electrical shock and burns. The use of PPE should be part of a comprehensive electrical safety program that also includes hazard assessment, safe work procedures, and regular inspections. Electrical safety is a shared responsibility. Everyone has a role to play in ensuring a safe electrical environment. By working together, it's possible to minimize the risk of electrical hazards and to protect people and property. In conclusion, the electrical code violations observed at the retail store serve as a reminder of the importance of electrical safety and code compliance. By following the NEC, using qualified personnel, and regularly inspecting electrical installations, it's possible to create a safe and reliable electrical system. Remember to prioritize electrical safety in all aspects of your life, both at home and at work. The NEC is not just a set of rules, it's a guide to ensuring the safety of people and property from the hazards of electricity.